Hello and welcome to episode 63 of the HamCorp training manual. In this episode, we will set up the first nuclear power plant cooling tower, which will house a liquid-cooled nuclear reactor, also known as a fluid nuke. Between episodes, I kind of just left my game running, and now we have some depleted thorium. I also made the heat exchanger, and I also made another nuclear reactor. So with this heat exchanger, I could, in theory at this point, with some redstone logic, start making hot coolant, or superheated steam. But there's no reason to do that until I can actually use the superheated steam. And for that, this quest will explain it. Not much to explain. It's just a different steam turbine. It's called the large HP steam turbine. This creates steam from superheated steam. So we're also going to need another turbine, just a regular large steam turbine, to convert the steam into energy. You also get energy from the large HP steam turbine, so it's a lot of energy. Now, I don't know how many turbines I'm going to need, but I figure there's no harm in making a few extras. So, a lot more crafting to go. But first, let's process this thorium, and then also set up this nuclear reactor so that I can get more thorium going while I work on this. Now, if you look at the uses for the quad fuel rods, there's this centrifuge recipe at IV. Don't do this. This is much worse than the thermal centrifuge recipe, because it seems like you get more stuff, but I don't think this is enough krypton to justify using this. The polonium has no use, and the tiny pile of thallium we don't need, and it's also easier to get through other methods. What we really care about here is the lutetium, and here it's 2 quad fuel rods for a 50% chance at half of a lutetium dust. So on average, you're getting a quarter of a lutetium dust for 2 fuel rods. But if you chuck it in a thermal centrifuge, you get straight up 2 lutetium dust per rod. So this is so much better. Now, I don't know exactly why I need this lutetium, but the quest book makes it seem like I need a lot. So it would be good to automate the production of lutetium. And indeed, there is a quest about automating fuel inputs. And the challenge here, basically, is that because it matters exactly where you put in your fuel, you can't just dump it in. However, for this design, I think you can, because the only allowed slots that will ever be open are the slots where the fuel is allowed to go in. But if you had a different design that had more empty spots, for example, that wouldn't work quite as well. If you have a setup like that, what you can do is you can use reactor platings to fill up all of the empty slots, because all a reactor plating does is it adds more heat capacity to your reactor. So it's not going to mess up the heat dissipation at all. And at that point, it's safe to just push fuel rods into the reactor. You will also have to make it so you're pulling out the depleted fuel rods, but you can do that with just an item filter. So I'm going to set up another nuclear reactor, probably just off to the side here. Not a permanent spot, but the building isn't really done yet, so I don't have the other rooms that I have in mind. So for now, I'm just going to plop it down here. I'm going to transfer all of these parts over, make another batch of quad thorium cells, turn it into lutetium, and I'll just keep going. For now, I'll just do it manually, because I only have to replace the rods every like 13 hours or something. And in the meantime, I can work on the steam turbines. I am currently in the process of building a cooling tower for a nuclear plant. It's not actually a functional cooling tower or anything. I just thought it would be kind of sensible to put the different nuclear reactors in different towers. And I've also thought about it a little bit more, and I think I do want to have just a separate Plapatronic supercapacitor here to store the power. And then this supercapacitor will feed the main one in our main power generation building. That way I can keep the logic, the redstone logic for the nuclear systems, separate from this existing redstone logic. And there's no chance of any unintended turning on or off of nuclear reactors. The towers are actually hyperboloids, but I don't know how to kind of realize that in Minecraft. I'll figure something out. I don't know. I'm going to do some building off camera, because I don't really have the means to do it on camera. I think a first-person time-lapse doesn't really look that nice. It's a little chaotic, especially the way I move around in game. I look around a lot. I've noticed that. Anyway, I'll be back once this tower is built. So I've started constructing this. This part of the shape is a little wonky. Not really happy with it, but it's coming along. And I'm using blueprints to kind of reduce the mental load here. I'm only going to build a little bit and then just rotate it and place it on each of the 4 quadrants. That way I don't have to keep going back and checking whether it's exactly the same. This way it's guaranteed to be exactly the same. Okay, the tower has been built. Kind of looks more like a cone than a hyperbola, or hyperboloid, but it is what it is. I'm pretty happy with it, especially if you look at it from a distance. That's not too bad. It is really blocky though, which I don't really like. But I don't know, is it really worth the effort to place these architecture craft blocks like diagonally or sideways or whatever? That's a lot of effort. Yeah, I don't know. You tell me. Was it worth it? I think so. I think this looks better. Now, ideally, I would make a second tower over here, but my god, that was so annoying to place these blocks, so I'm not gonna do that right now. I'll do it when I need it. The last part of this build is I need to add these like structural kind of supports that you see in the real life version of these. And I want to make kind of a diagonal ramp that goes inside. The inside is kind of just this empty space, which is not realistic, but useful for me. I've made a quick flowchart here to show how we produce EU from coolant and water and the fuel cells. So all the amounts here are per tick. So we start with a little bit of coolant that goes into our fluid nuke, which has been set up with the uranium fuel rods and the setup that I'll show in a sec. That's converted to hot coolant. The amount you get per tick depends on your exact fuel setup. So for my fuel setup that I've chosen to use, it's going to make 67.6 per tick. Now this hot coolant we combine with distilled water in the large heat exchanger to make superheated steam. But the large heat exchanger has a bit of a startup time, and in that startup time the inputs will be voided because it's like any other GregTech machine. It has the efficiency at 0% and it goes up to 100%. So in that time when it's between 0 and 100, a little bit will be lost, so we do need to replace the coolant. And also the distilled water, you could, at the end of this, you get it back and you could cycle it back, but I think that's more hassle than it's worth. So I'm just going to overproduce the distilled water in a distillation tower. And then the distilled water that we get at the end, I'm just going to void. So we have our superheated steam. These go into our steam turbines. I'm going to use large HSSE turbines. 2 of them will have the optimal flow rate of 4,800 liters per tick. And then we don't make enough for all 3 of them to be at optimal flow rate. So the third one will be a little bit lower. This will make EU and steam from the superheated steam. Oops, here's a mistake. This column of steam turbines should not be HP. These are just regular steam turbines. Multi-blocks, but not the HP ones. These work exactly the same. They're going to be set up exactly the same. And these just convert steam into distilled water and EU. The distilled water we're just going to destroy. So in total, we're going to get 33,603 EU per tick. Now, things to consider, fail-safes and such. Like I mentioned before, a little bit of coolant will be voided in startup. So we're going to have a replacement coolant thing, and I'm going to just have it trigger using a redstone signal. I'm going to have a buffer for the coolant, and when the cold coolant is below a certain amount, then I'll start generating replacement coolant. If we don't have the materials to make replacement coolant, then I'm going to shut the whole system down just to avoid any chance of the nuclear reactor going off. Another potential explosion is with the large heat exchanger. This will explode if we don't have enough distilled water, but that shouldn't be an issue. But what I am going to do is still going to have a buffer, and if the buffer drops below a certain amount, then everything stops. I think that's it for failsafes though. I don't see any other real points of weakness here. I don't see how the HP steam turbines or the regular steam turbines could explode, really. I could see them voiding things with maintenance problems, but I don't think they can explode, at least not with anything here. Obviously, I'm going to make sure nothing gets rained on. We have the giant glass roof, the glass ceiling. So yeah, let me put this thing together. I think I have everything set up, and I think I have it all set up correctly. I hope I have it all set up correctly. Just gonna start a backup, just in case, while I explain this. This is the reactor. It's accessed using this reactor access hatch, and a redstone signal is transferred to the reactor using a redstone port. On the right side, you can't see it. Well, I guess I could show you. We have these reactor fluid ports. These allow you to insert and extract fluids from the reactor. And inside of here, oops, I shouldn't have done that, is the reactor itself. So this is just our old reactor with a new setup, and it's just encased in this reactor pressure vessel container thingy. Now in here, I have a setup that's available on the wiki. These are iridium neutron reflectors. These are required because they're indestructible. Lower tier neutron reflectors in theory, could also be used, but they degrade over time. And these two spots are where the quad fuel rods of uranium go. So I'm going to put them in right now. Nothing's going to happen because the reactor's not on, because there's no redstone signal. Now, as for what I have set up here, oh, it's a lot. Here, I have a super tank full of cold coolant. It's just called coolant. The coolant is produced in this advanced mixer, but it's not produced forever. I have a fluid detector cover set to 1 million. So anytime this dips below 1 million, it's going to produce a little bit more coolant. But if it's more than 1 million, it's not going to produce any coolant. This is because the large heat exchanger has some buildup time, and a little bit of coolant is going to get voided every time the reactor shuts off and on. On top of that, in the back here, I have another detector cover. This one's set to 500,000, and it goes into this wireless transmitter. This is used to shut down the reactor. So if we ever go below 500,000 coolant, which should really never happen, considering the rate at which coolant can be produced, if it ever goes below 500k, then the reactor shuts down, because something has gone wrong. The transmitter, I used advanced mode to give this a name, because I just realized I could do that. And I'm actually going to go back to the main power plant and also use advanced mode to give that frequency a name as well. And I use 235 because uranium. This transmitter just leads up here to this receiver, which goes into a NOT gate because of how this signal works for the reactor. But this NOT gate is going to basically lead into this redstone port, and that'll start and stop the reactor. This mixer below here is being filled with lapis dust and also with distilled water, which I will come back to where that's coming from. And it's just being powered by a turbo combustion gen. Now this coolant goes into the reactor where it is turned into hot coolant and extracted. There are two ways to extract things from the reactor. You can either use an ejector upgrade, which is very slow, and you shouldn't do that, or you can just use a pump. So I have an electric pump here on the super tank. This super tank is currently empty, but this is going to be our buffer for hot coolant. I think I'm going to add another redstone failsafe here, another transmitter, so that if this tank ever becomes more than 95% full, then the reactor shuts down. Because if we're not able to extract the hot coolant fast enough, eventually this reactor is going to blow up. But I'll do that in a sec. So this hot coolant goes into the large heat exchanger, which I've placed sideways. The large heat exchanger takes the hot coolant as well as distilled water, which is produced here in this distillation tower, or quad distillation tower, and it converts those two into superheated steam and cold coolant. The cold coolant comes out of here and is just sent back to this buffer. So when this is operating at 100% efficiency, this is just a closed loop and we'll never need to make more coolant. The steam goes up here. The regular ender fluid conduits don't have a high enough throughput for the quantity of steam we're going to be moving per tick. So I had to upgrade to a melodic ender fluid conduit. This is an IV tier recipe. These conduits need PTFE, polybenzimidazole, and melodic alloy. And melodic alloy is this like mixer recipe, and then you blast it with all of this random garbage. Now the steam goes up into these super tanks, and on these super tanks, there are fluid regulators. These are like pumps, but you can set the exact rate at which fluid is extracted from the tanks. So in our case, we need 4,800 liters per tick, and that means we need at least an IV fluid regulator. And so here I have this set to 4,800. This one's also set to 4,800, and then this one is set to 3,920 because that's the remaining amount. That goes in here into the large HP steam turbines. Each of these has a large HSSE turbine. And then these feed the steam that's generated directly into these regular large steam turbines. These also have the same turbines. And these will finally return the distilled water, but I'm just going to void that. Here I have void overflow. I guess you can't change it. So the voiding mode here is set to void excess items and fluids. And we're just going to void the excess distilled water. Because we generate the distilled water here in this quad distillation tower, like I mentioned before, there's just a reservoir hatch, and it just makes distilled water. That's it, nothing special here. I do have a failsafe on this distilled water. If it ever goes below 4 million liters, which is 25% of this super tank, everything will shut down. Because that should absolutely never happen based on our rates of generation. So if it does, then something is broken or something happened. So after all that, we've got regular IV dynamo hatches on the regular turbines and the buffered 4 amp ones on the HP ones, because these produce a little bit more than 1 amp of IV power. So these get transformed up into LUV, and then this cable goes a little bit underground all the way here to this brand new Lapatronic supercapacitor, and this is our nuclear power buffer. And this is connected to the regular power storage in the power building through this vanadium gallium cable. Well, let's turn this thing on and see if it works. Alright, it's starting to heat up. It does seem to vary a little bit in the amount of heat units produced. Hot coolant is being made. This is starting to spin up now. And here are the turbines starting to go. Things are not at 100% efficiency yet, of course. This is still at 12%, so it's gonna have a little bit of a startup time. That's starting to look better. Now, originally I thought about using a power detector here with like the toggle latch to turn this off and on. But then I realized like I kind of want to just have this going all the time, because these fuel rods, once they're depleted, we can centrifuge them or thermal centrifuge them to get tiny piles of plutonium. And plutonium has been kind of hard to get. If you remember, we have a little bit of plutonium for the radon loop, but now we can get a lot, and we can upgrade the radon loop. And actually that kind of brings me to my kind of emergency side project. A lot of these chemicals are not being produced fast enough. Ever since we got the miners going all the time, we've just been gobbling mercury. I have no mercury at all. And I've also run out of redstone, which is a big problem. So I'm gonna have to go through the chem building and see what I can improve here. And another problem I've noticed is a lot of crafts have been getting voided. And it's not a power, well, it is a power issue. It's not an energy issue, in the sense that I have enough energy for these crafts, but I don't have the power. So I'm gonna probably have to add some more dynamos here or something. I don't know exactly what's going wrong, so I have to investigate that. But I kind of have some not that interesting but super necessary things to do. Fixing my power, fixing my chemicals. But I'm glad to have gotten this done, because this is going to make all of that a lot easier. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will address some immediate material shortages and power infrastructure weaknesses. After that, we will continue upgrading our power generation by investigating vacuum nukes or some other alternative. We will also upgrade our power and logistics infrastructure throughout the base. If you would like to complain about how the cooling tower is not an accurate enough hyperboloid, and that the diagonal ramp into the tower looks like dog shit, let us know by filling in the definitely anonymous feedback form on our Discord channel. See you next time.